Welcome everybody, and thanks for coming. Welcome to this UNSW campus. Excuse me, I'm delighted to welcome you all to this Thought Leaders series. And tonight it's about career advancement for the engineer of the future. My name is Ian Gibson, and I'm Deputy Dean at the University of New South Wales. Before we start, I'd like to acknowledge that we're meeting on Gadigal country here and pay my respects to elders past and present and extend that respect to any Aboriginal and Torres Strait Islanders that might be here today. My job is just to do a quick intro, housekeeping, etc. before I hand over to the panel. You probably would have seen bathrooms are just outside to the right. The building you can come and go at the moment. You can leave and come back. It's not on security for a while. The agenda today, we've got a fantastic panel and I have some questions that they'll be asked. After that, there'll be plenty of opportunity to ask more questions. Please do ask questions, because if you don't, I'm going to have to, and I'm going to ask really hard ones, and the panel doesn't want that. So please ask questions. Following the panel session, there'll be plenty of opportunity to network and mingle. We've got drinks just outside there. And so with that, I would like to welcome our moderator. So Lauren Gordian. Lauren graduated from the University of Sydney in 2017 with a Bachelor of Civil Engineering and Bachelor of Arts. She now works as a structural engineer at Northrop Consulting Engineers on various projects in the built environment, including industrial estates, education facilities, government infrastructure and residential developments. Outside of her project work, Lauren is a keen advocate for engineers in their early careers, volunteering as Deputy Chair on the Young Engineers Australia Committee for Sydney. She also co-chairs Northrop's Materials Climate Action Committee to complement her interests in sustainability. Please welcome Lauren.
Thanks, Ian. Similar to Ian, I'd also just like to quickly acknowledge the traditional owners of the land on which we're on tonight, the Gadigal people of the Eora Nation. Pay my respects to them and their elders, past and present. So I'm just the moderator for tonight. I don't have a PhD or much experience in the PhD field, but I'm going to ask questions to all of these panellists who have a lot more insight into the field. But before we get started, I'd just like to acknowledge that the event this evening is being hosted in collaboration between Engineers Australia and their industry partner, the University of New South Wales. So UNSW is one of Australia's leading research and teaching universities whose teaching gains strength and currency through research activities, strong industry links and international reach. In developing new ideas and promoting lasting knowledge, UNSW creates an academic environment where outstanding students and scholars from around the world can be inspired to excel in their programs of study and research. Partnerships with both local and global communities allow UNSW to share knowledge, debate and research outcomes. UNSW's public events include concert performances, open days and public forums on issues such as environment, healthcare and global politics. So tonight we'll hear from our industry experts, followed by a panel discussion and audience Q&A. Our topic for tonight's discussion is centred around the emerging industry PhD that is redefining the traditional PhD experience. The idea of solving real-world industry problems together with a tailored and accessible approach is anticipated to bring about new avenues for upskilling and lifting careers to the next level. Our panellists here tonight have all either completed or are completing a PhD, or they're experienced in this field. So our first panellist for tonight is to my left, Margaret Riley. Margaret was introduced to water as an undergraduate engineer doing in-course work experience with a local government organisation. Before she knew it, she was hooked into what had become a varied, challenging and rewarding career in the water sector. In early 2021, Margaret joined John Holland's Infrastructure Business Unit Senior Leadership Team as the General Manager for Water, with her role extending later that same year to include business optimisation. Currently, Margaret balances her time between her water sector responsibilities and cross-business continuous improvement and strategy. Can we all please welcome Margaret? The next panellist I'll introduce is Megan Lord. She's just sitting second from the left, or your right, sorry. Megan is an Associate Professor of Biomedical Engineering and Director of the Australian Graduate School of Engineering Industry PhD program at the University of New South Wales. She attained a Doctor of Philosophy in Engineering, Master of Biomedical Engineering and First Class Honours degree in Chemical Engineering from UNSW. Megan is a recipient of a prestigious Australian Research Council Future Fellowship and is internationally recognised in the field of biomaterials. Please welcome Megan. Our third panellist for tonight is Alex Suriadi, just here in the middle. Alex is an industrial chemist whose previous academic achievements include being an Australian Museum Eureka finalist and receiving both a Humboldt Fellowship and NHMRC Fellowship. Alex has published more than 40 papers, patents and conferences in the field of materials. Alex is a passionate innovator with focus in agriculture and has led the development of crop protection products for Salim Group in Indonesia. Currently, Alex is an adjunct lecturer at UNSW and co-founder of Joy Harvest and Leaf. Please welcome Alex. And lastly, we have Claire Bridges just on your right. Originally from the United States, Claire joined Associate Professor Megan Lord and her team in the UNSW Graduate School of Biomedical Engineering as a PhD candidate in early 2022. Claire's PhD research will advance understanding of the molecular changes that occur to the blood vessel wall during diabetes, which predisposes patients to cardiovascular disease. Working in collaboration with Syndogen Incorporated, this project will develop disease models and apply advanced imaging and biomaterials to inform the development of clinical interventions to protect and restore blood vessel functions. Please welcome Claire. So I guess just to get started, we'll start simple and get everyone to kind of answer a very general question. Why is it important for organisations to attract engineers with a diverse range of skills?
I can kick that off if you like.
Yeah.
I look at it from the perspective, an industry perspective, and if your organisation has an organisation full of employees who all come from the same place, they all have the same background, all have the same skill set, you are absolutely not going to be able to meet your current challenges. You will not be able to see risks that are just right in front of you, let alone further out in the horizon. You won't be able to take advantages of any of the opportunities that might be presented to you, and you are absolutely no way going to be able to survive as an organisation going forward. The environment that we find ourselves in is highly dynamic. It is way more dynamic than it has ever been in the past, and you absolutely need to have a diverse skill set, a whole heap of different range of experiences, depth of talent, depth of experience, different perspectives, looking at any one problem. So I see it as absolutely essential to survival as a business.
I can continue. I concur what Margaret said, and from a point of view of a startup or businesses that is not super big, like what I'm trying to say, if you are BASF, let's say you are the biggest chemical company in the world, you can have the best chemist, the best everything, then you can focus on one thing and be the best at it. But if you are like second grade or third grade or a small company of a startup, it's really hard to have an innovation in one field. But it's much easier, and this is what I believe, innovation comes when you have two different skills or two different sets that meet together and learn from each other. That makes the innovation much easier to come and more natural to come. And that's in the world now that we do have a lot of, let's say, a lot of big challenges, existential challenges in some of them, like climate change, food securities, and that's the part that I'm working in. We need to get solution fast, and if you just have one set of skill, the solution might come, but it will come a lot harder.
I guess Megan and Claire, for you both, you're working in the university space. Do you observe anything in industry as to how a diverse range of skills benefits organisations, and I guess what university education can do to encourage a diverse range of skills?
So in my research, and Claire's part of this in our team, we work a lot with industry. And so in Claire's introduction, she's working with a startup company in the US, in California. And the great fun we have there is that we have both academic and industry perspectives of solving solutions for the startup to innovate. So I think we bring together different training. So we work with chemists over there and we're engineers here. So we have the different training, but then our different academic versus industry perspectives really add to a diverse team. So I think it's the same whether you're working solely in industry or both across into academia as well. The same things really benefit.
Absolutely. I think one of the best things about training engineers in general is that you really do end up training people to think creatively about problem solving and not just, I know how to do this problem, I've seen it before, but to actually take all the information we have and be deliberate in looking for new ways to solve problems. And doing that with a diverse background really helps. I have sort of a weird background as well. I'm also a theater nurse, so I have a little bit of that clinical side. And in my own work, I find that's quite useful because I can notice things that might not be quite so obvious if I hadn't been in that situation before. And I've worked with other clinicians or other researchers and students and academics at the university who have industry experience from a variety of professional positions, whether they're mostly in teaching or in more industrial manufacturing, and they're able to give a perspective that lets us learn to look even more from a wide perspective that makes you more creative and better at addressing whatever problems that you're coming across.
Yeah, I think that's a really valuable example there, and is something that's happening right now with your experience. Claire, I might stay on you. Can you tell us a little bit about why you decided to do a PhD, and I guess more specifically in this instance, an industry-focused PhD?
For sure. So I started a PhD mostly because I wanted to move back into the medical research world. I did my undergrad in a biomedical engineering degree and then moved into nursing for a little while. And nursing is lovely and has a lot of personal reward in being able to interact with people one-on-one and help them and help improve their lives or their situations, whatever you're dealing with at the moment. But research really gives you a much wider impact. And so even if my research is only ever, I tried this and that didn't work, maybe somebody else won't try that and they'll find the right thing. And so to be able to contribute to something that could affect and benefit a really large array of people is something that was important to me. So that's why I wanted to go back into the research PhD world. And the industry PhD is an interesting specific label that we're starting to put on things. I think that engineering PhDs in general are quite unique because most of the time we end up doing hands-on experience. It's hard to get a purely theoretical engineering degree or engineering PhD, but to have the industry PhD, that's the program that's being, I guess not founded exactly. There are other industry-related PhDs in other universities, but certainly being formalized by UNSW is quite nice because we have built-in internship work and direct links with industry, direct opportunities for professional development and continuing education so that when you leave with your PhD, you have this piece of evidence that says, I've been doing this in an industrial setting. I haven't just been in the classroom talking about, well, theoretically, if I had this problem in my professional workplace, but I've actually been there. I'm putting this into practice, and I'm comfortable with doing that. And that is, I think, a really beneficial thing that you can apply even if you end up staying in academia, the skills transfer.
Yeah, definitely. And Megan and Alex, you both also have PhDs. Can you tell us why you decided to do a PhD?
Okay, I'll go first. So it was actually during my undergrad program that I was doing an industry placement, working in a medtech startup company. And it was a really exciting time to innovate, and I could see how important R&D was to the growth and survival of the startup company. But it wasn't actually until my honours supervisor said, hey, you'd be really good at doing a PhD, that I made that link, that doing a PhD would help me stay in that startup space. So I never got there, but what I do is actually work with companies a lot in the startup space in my academic world. Through the PhD journey, what I really enjoyed was the freedom to explore and to discover something new, and that passion stays with me today in everything that I do. I was a very cheeky first year PhD student when my supervisor said, I'm going to Germany for a conference, and I said, well, I'd like to go too. I hadn't been to Europe at that point in time, and so he turned to me and said, well, get funding and then you can come with me. So I did. I got an exchange program funding from Germany, and so then I saw myself 6 months into my PhD presenting my first conference presentation on my early work on my birthday in a room named after my high school here in Sydney. But what that trip also did for me was let me go and work in labs around the world. So I got to spend months working in a lab in Denmark and in the UK. So it very quickly gave me this experience that doing a PhD isn't locked in a lab on your own. It puts you on the global stage. And it does it for a lifetime, and you see that your research has impact globally. And to this day, I still work with those people that I set up those collaborations with in Denmark and the UK. It taught me a lot more about myself. People think about a PhD very much as about the technical skills you gain. I very quickly learned what I was capable of, and I think we need to do more of that in our PhD training.
Yeah, that's fantastic. Alex, would you like to share your story with us?
Yeah, sure. There's that part, but there's also a bit more real. I'm unlucky to live through the period of global financial crisis. So the reality is I did PhD because I couldn't find a job. So that was because I finished in the 2009-ish. But having said that, during my undergrad, I was also working for BlueScope Steel at the time, and I couldn't find a job. And there's this actually an ARS, what is it called at the time? It's like a PhD with industry as well. So I get to do that job, to do that PhD, which I'm really glad I did. And that time is actually quite perfect because they are BlueScope Steel, have this PhD program, and then afterwards you work in BlueScope Steel. And they are at that time, this is when I talked to my both academic supervisor and also industry supervisor. We are building a team, we need more R&D people, we need more technical people, and we are growing into Asia. And I know that they have a factory in Indonesia that's actually not far from where I come from. Okay, this is perfect. I will do 3 years PhD, and then after that I will go home, being an expat, earning Australian salary, Indonesia, perfect. By the time I finish, another global financial crisis. BlueScope still closing their lines, so I couldn't get that job, so I continue become a postdoc. But having said that, a lot of serendipities thing happened. So then I get to live in Germany for a bit, get to live in England a little bit. So that's, like Megan said, that gives a lot of opportunity, not just the technical things, but learning how things are in a country like Germany, how things are in a country like England. So that has given me a lot of friends, a lot of networks, and a lot of different kind of knowledge and then now I'm a startup founder, and that's give me a lot of knowledge, I guess, that I can bring in.
I think the common theme I'm gaining from both of your experiences is that a PhD gets you to travel and have a lot of unique opportunities to meet new people and network, which is, I guess, something that I wouldn't normally think about if I was to consider doing a PhD. So that's really interesting. I guess if we move back into the connection with industry now, Margaret, did you want to start with this one? What challenges do you see organisations are facing now and into the future?
Yeah, so I touched on a bit about the risks and opportunities that we're facing. And to be specific, climate change is one of the biggest ones. Australia's been lagging behind in terms of policy and direction for quite some time in terms of the global community, particularly Europe. And we are catching up, and certainly a lot of big announcements in the last 6 months in particular, and they're very ambitious. And the reality is that our industry, and I'm not talking just construction, but more broadly utilities, et cetera, don't actually have all the solutions right here and now. And in fact, not all those solutions it's not just available domestically, it's also what might be available to us in the world. Because you overlay some other complicating context, which is resource issues. We have very ambitious programs about what we want to do and how quickly we want to change and move to a net zero state. Yet where are all the engineers coming from? Where's all the technology coming from? Where's all the manufacturing industry to be able to support all of that? So, having to look at different ways of doing things and getting there really quickly, and which means not doing things the way we've always done them either, and requiring a lot more collaboration, so between industries, with industries in the university sector, as ways to really meet those challenges. I know I also look within our sector as well, so John Holland is a construction company. There's a lot of research that's been done in our field around productivity and the lack of productivity, and the fact that we've got this big gap of productivity gains that are there that we actually need to take up if we're going to continue to be competitive, but also survive in the marketplace more broadly. Because again, like all industries, we compete against each other for top talent and resources as well. And so from that perspective, we look at needing to harness different ideas, diversity, the diversity of thought and thought leadership to be able to support that change. And certainly what we're seeing now is a lot more collaboration with startup organisations, with universities, bringing in technology applications, co-developing and designing those with industry. And there's been quite a proliferation, IoT, some of the space and GIS information systems, I'm thinking digital twins, that sort of thing. A couple of years ago, they weren't really out there, maybe a bit of 3D modelling was sort of BAU, but digital twin is now front and centre, and then going, okay, well, what are all the opportunities that open up once you have full digital twins opening up? Not just for construction and design, but also then the operation and maintenance of these facilities that you're building. And these are long-term 50, 100-year facilities. Maybe an energy asset, maybe it's a health asset, maybe it's a water asset. So there's a great deal of opportunity coming, not just managing risk.
I completely resonate with that, because I work at a consulting firm, and we have all of these committees. I think Ian mentioned that I'm on a sustainability committee at work, which we have all of these ambitious goals for tackling the climate change issue, but it is, where do you find the resources to do that? And if that's not your priority at work, where do you find time to make it a priority? So I think that I guess universities can help out in that field, and it'd be good to hear now from you guys as to how that connection is made, and what you're seeing universities are doing to help organisations tackle these issues.
Well, if I take the first part on that one, I think it's important to think a little bit about what PhD training offers people, because we've heard from our industry panellists that we need different ways of thinking and ability to innovate. What a PhD essentially is a degree that trains you in problem solving, complex problem solving, critical deep thinking, and with that comes new ways of thinking about doing things. So A great example from one of my other PhD students in the last couple of months was they were faced with processing a whole lot of images. They didn't have the time before they started their grad job this week, to sit and process hundreds of images. So very quickly they wrote a program to automate that and do them for them. And it wasn't something that I'd asked them to do, had thought about them actually doing in their project. I thought they'd just sit there and crunch the images. But the training teaches you to think differently, to solve the problems really quickly. The training also teaches you resilience. So it's very often that we do an experiment and you get the answer you expect, or you get part of the answer you expect and you get so much more information. So pretty much every experiment I've ever been involved in, I've been told I'm wrong with the data. So part of that is that resilience to pick yourself up and head in a new direction. There's also a lot of resilience in the debate and the direction that your research takes. And as you go further in research, you have to get funding to fund your research, and they're hugely competitive. So very often you're told you're not good enough, you don't get funded, but then you work on your ideas and you get better. So that resilience is really built into the training, and I think that's valuable for industry as well. You talked about collaboration, and now industries are thinking that collaboration is really important to develop solutions in a timely way. The PhD cannot be done on its own, on your own, sitting in a room. You're taught from day one to collaborate and to work together. And then there are things about communication. So we think about communication just in the technical, but now more than ever we're being trained to communicate to society, to industry stakeholders as we work together quickly. So I think I've just touched on some of the skills where we think about a PhD as a technical degree, but it teaches so much more valuable skills that I think PhDs can offer industry, part of that diversity of thinking to solve challenges for the future.
Great. Did Alex or Claire, did you have anything to add to that?
Yeah, I can add to that. So we are a startup company, and our focus is we're developing materials that is to make food productivity, to make better food products, increase yield, or changing nutrition, or changing the harvest season to get better timing of the harvest. And we want to do it in a sustainable manner. So I think what working, and we are working very close with UNSW, with other universities as well. We are part of CRC Future Food. To me, working with the academic is very important. As an industry, one is there are some risk that we cannot take, especially if we already take investment money. The investor will ask for return on investment and all these things. So we cannot do a more fundamental study. So for example, as a company, we have proven that if our technology do on leafy greens, we will get an increased yield. But we don't know yet if we test it onto like a tomatoes or blueberries, can we improve the nutrient profile? So we can't answer that by ourselves. So we work with the university to answer this a lot more complex, because you need a lot more analysis. Obviously, now you're not just measuring things by weight, but you actually have to extract things, you have to get more equipment. These are things that we cannot access, but working with university allow that. And then two, also, it's allow us to get scientific validation, not just to the market, but also to ourselves. Because for us, for example, when we do these things, because it's something that is new, every time we go to a potential customer or whoever, different stakeholders, it's not once or twice that people look at it like, nah, I think there's got to be something wrong. This is not right. Because you can get improvement that the industry haven't seen. But of course, because it's something that the industry haven't seen, so you don't know. So if you as a company, you're saying that, especially a very small company, then there's a lot of, you need to validate. And working with a third party, like a university or a different research institute, allow us to like, okay, we hands off, we just hand our material and let the researchers and scientists to do their magic, and then, okay, now the result, we can be more confident. What else? I think these two Plus, then making something that is novel and working with someone that is, let's say they're doing PhD or they're doing postdoc or whatever, then the knowledge is also very unique. And that's not a talent that you can easily put a job at or something. Then if you can already have a working relationship, then I think it's a win-win, because now the PhD student, let's say, or they know if once they finish this, they can work in this industry, maybe with us, maybe with someone else. And for us, that's also become a potential source of talent.
Yeah, that's a great connection between the two. We touched on a little bit earlier about, I guess, this stigma that a PhD or even a master's degree can carry in industry in Australia. I guess in that being, if you stay at university to do a master's or a PhD, you're not getting that industry experience. And so when you actually want to enter the industry, it's a lot harder to get your foot in the door. How is the kind of change in the PhD program at UNSW planning to tackle that?
Well, if I step back and then answer that, and Claire jump in, talking a lot. During a PhD program, you're surrounded by academics in a university environment in its classical sense. So our PhD students see academia as a major pathway for them if they're the role models, and then incidentally might be a family member with a PhD that might have a different experience. Or it might be incidental at the moment that you're working with industry and know someone in that industry with a PhD. So I think we haven't created an environment where our cohorts see PhDs beyond academia, and we need to change that. What we have also done in our engineering programs is very much focus on undergraduate engineering with the internship, having that industry experience, having degrees that are accredited by Engineers Australia. So we've developed our undergraduate program very closely in partnership with industry to meet industry requirements. And then more recently, we've been doing that with our master's program as well. But the same is not so for the PhD. It's not a regulated degree in terms of professional development, and so it's very much focused on academic skills. I think while we develop a lot of skills that I touched on earlier in our graduates, we don't equip them to be articulate in what those skills are, and we can do better there. And what we can also do better in is explaining in events such as this the value that PhDs offer to industry. The reality is that more than half of our PhD candidates at graduation enter industry. There aren't the academic roles for them, and so we have graduates that feel a little bit lost straight at graduation about what their career path is, and we need to do better there. Some of those that will stay in the university will do so for a few years and then enter industry or organisations apart from the university, because jobs like mine don't turn up every day. I'm one of those really rare people that have stayed in academia and still love it. So what we're doing is working through the program we've set up in the Australian Graduate School of Engineering is to do training more in partnership with industry, recognising that's where most of our graduates go, recognising our skills are really valuable for industry. And so Claire touched on that program a little bit earlier in terms of equipping these people so they know what their skills are, giving them more professional development training, and that's tailored to the person, and creating networks not just with their industry partner during their PhD, but with the breadth of industry that work with UNSW Engineering, so that these people graduate knowing who their future employer potential options are, and vice versa. And I think we'll have great progress in doing this.
I have a personal feeling that the sort of idea of a PhD in engineering is too academic for people to go into industry doesn't really make sense to me, because I see what I do all the time and what my colleagues do, and how the wide variety of work that we do and how that gets applied to different projects and also different tasks or requirements in the university. And it's all transferable skills, but I think exactly as Megan's pointed out, it's not necessarily obvious, especially to somebody who hasn't worked in industry, that what they are doing when they are helping TA and teaching a class and presenting that information, or optimizing and coming up with a brand new protocol that hasn't been done before, that those are things that are valuable and are skills that would be needed in an industrial setting as well. And so the formalization of that with this industry PhD program is really great to help highlight not only what we're already being trained to do and how that transfers, but also to look at what each individual student wants to have in terms of a transferable skill or an industrial skill that they can directly try to target and learn more about. And that extends as well, I believe, just to sort of connect with the idea of facing challenges in industry that we maybe haven't trained for back in the day for people who have been working as engineers forever. AGSE, I know, is looking at presenting more continuing education and professional development as well for people who are not just in the PhD program, but to kind of bring some engineers who want to pick up more on things, for example, like climate change, which probably weren't taught quite the same way that they are now when a lot of people got their engineering degrees. So to bring them into the university for that collaboration, and then to also connect those people with the industry PhD students or the other students doing PhDs gives more collaboration, more opportunities to use that diversity of viewpoint and experience that we were discussing earlier. And I think that can only help with those transferable skills as well, to see where you actually can fit in, even if it's not your exact PhD project directly translated to a specific company.
Yeah. I think, it seems like industry professionals and people in academia doing PhDs are actually very similar people, you know, like we all network, we all travel for work, we all have all of these different experiences and opportunities, but it's just merging them together to network with each other is something that I guess this is going to work on. Alex, when you were doing your PhD, you were working with industry already. Did you see, I guess, what was your experience like in, I guess, terms of perspective with the connection more to academia rather than industry? Did you notice that, or did you not pick up on
the difference, I guess?
Yeah.
Yeah, I think when I was doing PhD in the BlueScope Steel, for example, their aim is, for my project anyway, is to analyze their product, color-born product, or to come up with the new ones. So of course, industry don't really care much about publication, the journal publication. They care about a product or a patent. And that is, of course, a little bit difficult if you want to have an academic career, because that is what's important for academic career. So I do have that struggle as a PhD student, because I think at that time I was the only one that have an industry funded project. So everyone is like, you know, every group meeting, so every month they have like, oh yeah, we do this, like we can publish this, we can publish that. And I will be like, okay, my project is secret, cannot tell anyone, and how do I go to conferences? That's kind of like personal struggles. But my supervisor also, and my industry supervisor also quite open, like as long as the things for us, you keep it for us, but you can explore it for other things. You can do the things that I was focusing for academic purposes. So that was a good balance there. I feel like when I work in Germany, for example, like because that thing is more common, so the industry there is also more. I think they just already have a framework on how the IP is going to be divided, and I feel like here maybe the industry is a little bit more scared compared to Europe, for example, because they are already like, as long as there are things that's agreement. And that's how I see it as well now, as because now I come from the industry point of view. yeah, this technology, as long as when we say we use this, as long as whatever this is kept as a trade secret, we can publish the result, no problem at all. Because the result is for scientific advancement. As long as that you don't tell the world that this is what you use, this part can be published. It's no problem at all for my point of view now as an industry. But yeah, I think that's probably a balancing act that need to be done. We heard a lot of here as well, like from other startup or other company. How is it working with university IP? Of course, it's an issue. Who owns it? And that seems to be, with some universities, not an easy topic. But I have to say, I think UNSW is the best in the country, with my experience so far and what I heard from other people. I heard like a concept of like what's yours is yours, what mine is mine. What we work together, we have together. I think that's a good general concept, I feel.
Yeah, that's good. Megan and Claire, I was just thinking as Alex was speaking then, do you find it difficult to, I guess, connect PhD students with industry organisations, or is it quite easy if a PhD student has an interest in a specific topic? Are there plenty of organisations out there looking to help sponsor these topics?
Certainly in my space in the med tech field, I work with companies here in Australia, so I've worked with Cochlear and I've worked with the Red Cross Blood Service. But our med tech industry is predominantly startup and growing. So I get more opportunities to work with companies overseas, and I'd love to see us do better in that space to work more closely together. The way the projects work, it's often industry reaching out or me through my network saying, have you thought about this? Is this fitting into your R&D pipeline? And then the student comes later so that you get the funding to make it work, whether that's directly from industry or it's through some of the granting opportunities, and then the student comes on board later. So it is like a job advert that goes out for the PhD student to join a particular project.
Yeah, great.
Yeah.
And you don't find any struggles in finding a PhD student for kind of every role?
We do. So that's one of the challenges we face. So engineering at UNSW has about 1,000 PhD students, and we have about a third of those domestically. So most of our undergraduate engineers go out to industry straight upon graduation, and what we'd love to see is more of our domestic market staying with us a little bit longer or considering coming back for a PhD after a few years of industry experience. And certainly there's opportunities with interested industry to maintain employment for their employees and work at the same time towards their PhD. So then industry can develop their own talent and develop their skills along the innovation pathway as well. I think what we need to do as a country is change the view of what a PhD does and get it solely out of academia. And if we do that successfully, then more people will see the value in doing a PhD.
Yeah, definitely. I guess we have moved a little bit onto the next question, which was what are the challenges of PhD training and partnership with industry? I might throw it over to Margaret because we haven't heard from you for a little while. So maybe you can talk on the industry side.
Yeah, look, I think from the partnership perspective, sort of just touching on what you were finishing there, is like how you make those connections. Knowing that you've got a problem that maybe somebody else could assist. And I think that's part of breaking down the silos. We often consider our businesses in silos, our sectors in silos, and that's part of the challenge is breaking outside that thinking to reach out to other organisations. And then, some of the other elements can sometimes be around cultural fit as well. So how industry groups operate. I mean, actually, when I first started work, I was running a research and development program with a government utility, and we had in our cohort several PhD candidates. And part of, I think, the challenge that we had, particularly in the initial stages, was just some of the cultural alignment. And I really embraced the idea of these, very industry-specific programs that you're developing where you're also looking at other skill sets that you're going to be training people and upskilling people in, because it does help to make sure that we're all speaking the same language.
Yeah, great. Alex, did you want to follow up from that? Did you have any?
Yeah, I'll just continue a bit from the language point of view. I think sometimes, and I'm guilty of that, after you do something for so long, very specific, your mind keep using the same words or same thing, and when you talk to people, it's like, I don't know what you mean. And then I actually a little bit inspired by Big Bang Theory, because Sheldon's mom, I don't know if you guys following, but Sheldon is a super smart guy, and then Sheldon says, Sheldon, I know you're smart, but if people don't understand what you're saying, actually it doesn't have any value. Oh yeah, that kind of things I think is very resonant with doing PhD, and then if you actually cannot iterate what you're trying to do, and you're being too technical, that's a bit pointless in a way.
Yeah, and I think the other thing that we had, certainly with our space, when I was looking after the programs, it was, the needs of industry have to be met through the programs as well. And there's a timely component, there's a cost component to all of those. And to be frank, they are fantastic skill sets to be developing through your PhD program, because they are directly translatable to anybody's career, whether you're moving into consulting or a technology partnership, if it's a startup, or any of the other sort of organisations. Time, cost, quality are big focuses, and if you can demonstrate those skill sets through your PhD program, it's brilliant.
I think it'll be nice to see how things continue, especially not just with PhD, but higher degree by research programs in general, kind of bringing all of these together. Megan's mentioned sort of redefining what a PhD means to people who aren't in it. And I think as we have more of this industrial input into these programs, and we start seeing more and more graduates who already have some of these skills, some of the kind of continuing ed opportunities that they're looking at for us are specifically things like risk management, financial risk management, even though you're in a biomed sector, or interpersonal things, or how do you communicate your research and your skills to either people you need to invest who have no background, or to the technical board of your company who genuinely need to know every detail. And as those come together, I think we'll find that more and more people in industry will also then gain that sort of academic collaborative viewpoint, where I very frequently, if I don't know how to do something, I look around at the pod of people who sit near me and I say, oh, I know you do this all the time. Could you help me? Could you teach me? Could we talk about how to do this? And when you have that mindset that I think is often developed through research degrees, then when you end up in industry and you go, oh man, our company would be really well poised to do this, but we just don't have anybody who has that expertise. Who could we ask for it? Well, maybe you already know somebody from your training, or at least you're in that mindset to be able to reach out a little more easily than being quite so siloed as you put.
Yeah, I think that's so right, because even though in industry, if you've graduated with an engineering degree and you have those technical skills and you're using those technical skills in industry, you still have to kind of have that business frame mindset. You might not have done a business degree, but you pick that up along the way. And so it makes sense that people who are like in the academic field also need those skills, and they are very easily transferable over to industry later. I guess one other challenge that we touched on a little bit earlier was the idea of intellectual property when you combine academia and industry. Megan and Claire, have you come across this challenge at all yourselves, and how has it been dealt with?
Yeah, so it's a precursor to starting any project, and so we've been thinking about it a lot, particularly in our industry PhD program, to have realistic agreements in place, acknowledging where background IP sits, whether that's in the partner or within the university, and then who is going to take ownership of the project IP at the end of it. And so there's various models and flexibility in that. And then that extends to clauses around publication and then confidential information shared during the project must remain so. So as Alex very nicely said, we're aware of this, we have those agreements in place, and then they get refined in the partnership before you actually sign the agreement. So they can end up looking different from project to project, depending on the circumstances. But I think we're getting the balance right, that ultimately these technological advances, this knowledge is best harnessed by industry as the vehicle to make it accessible to society. There isn't any point keeping IP in a university and not allowing it to be developed. So I think we've got to a point where we're quite realistic on our position, but we're certainly part of the solution.
Yeah, it's great. Very collaborative. Margaret, have you worked with PhD students in your role so far?
Not in my current role, but certainly in previous roles I have worked with PhD students.
How was that?
Yeah, it was really great, really rewarding to be part of creating something new, investigating new ideas without actually having to roll your sleeves up and do all the dirty work. So it was fun to watch. So yeah, it was really great. I learnt a great deal from it because certainly there's this real depth of exploration going on in a particular topic, and you can't but help be dragged into that as well. But then also seeing the fruits of that, a couple of years down the track, and then how that's going to be applied into your particular business. So it's a really great journey to go on. It's an emotional journey to go on. You travel that with the PhD candidates. Unfortunately, we did have one that had a wobble and needed to have some time out of their program, but thankfully came back again. But understanding that journey that they were on when they met frustrations and things weren't necessarily working, and then they all came good again. But we also knew too, and the reason why we were really excited about supporting that was because we didn't have the skill set in our business to be able to solve it on our own. We didn't have the time. We didn't have the access to all of the resources that the university did. We weren't going to go set up a specialist lab. That would cost millions. Hey, the university already had that ready to go. So why wouldn't you leverage all of those benefits that are already in place? So it was a really great outcome. And then, also from an industry perspective, there is also some tax benefits from doing these things as well. And as well as then you have access directly into a talent pool of people that can be taken on board into your organisation as well, and their network, which is also good.
Great. Did you bring any of your PhD students into John Holland or wherever you were working at the time?
I don't.
Did you see anything?
Yeah, I think they ended up in academia from memory. I don't actually. I don't think they found their way into our business, but that wasn't because we didn't offer the opportunity. Certainly, that was there. I think it was just where their paths happened to take them at the time.
Yeah. Great. I think we'll move on to a couple of questions that came in from the registrations, and then we'll open up the floor to anyone else who has any further questions. So the first question is directed more towards Margaret and Megan. There appear to only be a few engineering job vacancies at employment agencies, including Centrelink, in spite of the claims of engineering skills shortage. Can either of you pinpoint the reason for this, in your opinions?
Yeah, look, it might be looking at that particular location, so Centrelink, probably not the space to look for engineering opportunities. So sort of better places to be directed toward would be things like LinkedIn, Seek. There are enormous numbers of engineering opportunities posted on those platforms. The other is to reach out to organisations, recruitment organisations. They are always interested in looking for people's CVs and connecting with people that they can place in organisations. And for those people who are recent graduates, there's also an ability oftentimes to connect to your university. They will often offer career services to recent graduates, and we'll support them for some period of time afterwards. And then lastly, it's finding out a little bit about maybe your target organisations that you're interested in and approaching those organisations directly. But I can absolutely guarantee you that right across the engineering sector, whether we're talking about consultancies in the construction space, in research and development, in biotech, there's a whole gamut of organisations that are very hungry for great talent.
Megan, did you have anything to add?
I'd just add that we're seeing very high recruitment rates of our near graduating cohort at the moment. So I had my class today, and many of those will graduate at the end of the year, and pretty much every one of them that I had a chat to said, I've already got a job lined up.
Yeah, I mean, we're seeing, I think we had our graduate intake this year, and it was phenomenal, the numbers who had positions offered to them, within, I think it was more than 10 months out from actually finishing their degrees. So, they're certainly there out for offer. I think sometimes it's also about positioning yourself with those organisations, how you're promoting your skill sets as well, thinking a little bit outside the box, so to speak, in terms of what you can offer. Because we've had a lot of conversation about engineering degrees more broadly, whether that's undergraduate, masters or PhD programs. You are so much more than your technical skill sets.
I might add, very small, finance.
Yes.
Because my wife from chemical engineers, but now she works in finance, and apparently finance banks now really like to recruit engineers to do modelings and algorithm and stuff like that.
Yeah. I remember when I was at university, there were so many kind of different organisations that I had heard of who weren't in the engineering space. They were just business consulting or in the finance sector who were actively seeking people with engineering qualifications just because of the non-technical skill set that we learn.
Absolutely. It's that creative problem solving, that holistic view of things. I know from my undergraduate university, the big four consulting companies each run their own consulting recruitment days for that targeting that engineering non-technical skill set of you can look at this and see, you've been taught to see all of the things that go into this. So I think if you expand out of just pure technical, you'll probably see a bit more options.
Yeah. The next question that we got through from our registrants was something about space engineering. NASA now has Australia as their very first spaceport outside of the USA. Very exciting. Are we going to take advantage of this and develop our nation into space industries and therefore start grooming our toddlers of today who will be the space engineers over the next 2 decades?
So I had to phone a friend on this one, my husband, and because I'm nothing to do with space engineering. But you'll be very pleased to know my 5-year-old already has a NASA space shuttle toy. The reason largely behind NASA being here in Australia is that the University of Queensland has a long history of very successful space engineering research, and some of you may know that they've been doing it for over 30 years and have had a memorandum of understanding with NASA, particularly in the hypersonic flow. And I had to ask my husband because that was what he did for his undergraduate up in UQ. So the reason we've got NASA here is our long history of being really strong in that area. And I'm pretty excited about it. I'm not a space nerd, but I think it creates great marketing, particularly for our primary school students and our high school students, to engage in the wonder of engineering, particularly with the potential of space. So I'm very much welcoming NASA being here, and I see great excitement for us to transform our ability to recruit enough people into STEM with this great example.
Yeah, and I think it's a great example of build it and they will come.
Yeah.
So, once you have these sort of pioneering initiatives, like say NASA or a university program, that sort of thing, that it often creates an ecosystem around it as well of industry, and whether that's the tangible assets to support that industry, or maybe it's a technology-focused one, or maybe there's something about training, or it's so many facets that it can support, and I think, and then that also goes to help support the buzz in our schools and our education system more broadly, which is great.
My office is in Cicada Innovation. It's like a deep tech incubation owned by UNSW and a few other universities. And now suddenly one whole floor is all space companies. And now they have space event every 2 weeks or 1 month. And I do think that space is perhaps one industry that Australia will have a clear edge, both from the technology point of view, safety, geopolitical. There's not that many that I think NASA can work with, and I think Australia should be definitely one of them.
It is pretty crazy to think of how, children are going to view the world today compared to how we all viewed the world like 20, 30, 40 years ago. The next question that came through was the level of knowledge with basic structural engineering design skills of students graduating and starting at a consulting engineer's office has been diminishing year by year over the past 30 years. What will be done to increase the structural design skills of students whilst at university?
I almost feel like you should
Well, we were discussing this one before we started, and I said I've been in industry for 6 years, so I was probably one of these students who didn't have the same level of design skills as someone entering the industry 30 years ago. But I also wouldn't really know. But I think for me, who's at a point in my career where I'm starting to mentor and teach our undergraduates and graduates at work kind of how to transfer their engineering degrees into industry, I feel like it's almost expected that they don't know how to tie the two together. And I think that's because of what you learn at university is a lot of those skills are transferable over into other industries. And because of that, you're not necessarily going to focus on a specific industry problem unless you are dedicated to it. Yeah.
So I'm not a structural engineer, but I have been in the university sector for a while. And the way I approach this is we've created our undergraduate programs very much in partnership with Engineers Australia to get through the accreditation process. So through that, we've listened to industry of what is most critical for them to have in a graduate. And what we see is that's a balance of technical skills and those transferable skills that we've been really focusing on tonight in our discussion. And so there's only so much we can cram into a 4-year degree. And what we've been moving our program more into is teamwork projects, so experiential learning, rather than just sitting learning the basics, rote learning, gathering knowledge. So we're trying to equip our graduate engineers with a lot more skills than just the technical skills. And at some point there's a trade-off. But it's a continuing dialogue between the education program and industry needs. So I encourage anyone to come forward and chat further if there is a particular thing that we're missing, and then we'll see what we can do to fit that in our program.
I have an idea for you. Why don't you make a course that is practical and ask the students to do it outside of the university? I am a structural engineer, and I faced that when I graduated. And really, what you learn at university doesn't apply to the practical market outside. So all you need is just a 3 months period, like a course at a consultancy office where you learn the design and what is required, and you can conceptualize in 3D what a building is really like, and what the the iron bars are supposed to be placed, work in the field itself for 3 months, and they come back, and you'll have no problem at all to fitting into the market.
I
It
guess
should be like a course in the university before graduating.
I guess we do kind of do that already with the internships. I guess in order to get your accreditation with Engineers Australia or your degree, you have to do the 12-week placement. And for me, I guess for some people, they will do their 3-month placement in, say, at a civil engineering consultancy, and then decide that they don't actually like civil engineering, they want to become a structural engineer instead. So they do end up becoming a graduate engineer at a structural firm and then don't know anything about structural engineering. So that's probably one gap. But for me, I did an structural engineering undergraduate internship, 3 months, and then went on to become a graduate a year later. Yeah, definitely. I was, when I started my engineering degree, I didn't actually know what engineers did, so it took me a while to play catch up and actually learn what I'd be doing for my career, so the internship was very helpful. But I love it now. Yeah, anything to add to off the back of that? Yeah, it'd be interesting to discuss more once we've concluded. The last question that we had from registrants, and then we'll let anyone else ask some questions. Is there a way to become a digital engineer from starting off as a mechanical designer or engineer? I think, Alex, we were going to direct this one to you.
Yeah, if I understand the question correctly, I guess because there's no course as digital engineering. So as an engineer in the startup world, when you say you are engineer, people think of you as the programmers, which I think that's what the question means, like this digital engineering in the Internet of Things, e-commerce, SaaS kind of things. So I think because there's no degree for that, most of the people that is good at this kind of thing that I know is mainly they do it, they learn by doing, I suppose, whether it's with a company or just learning yourself. I mean, these days, some of the crazy programs that people met, chatbot, like to buy sneakers, the fastest is actually made by like high school students. Yeah, I don't know if this is something that a university should have a formal course, but seems to me anyway, this is something that the world is moved a lot faster than the education, I suppose.
But it's whether or not it's also required, necessary to have a formal start in it as well. It might be something that you commence with experience and then come back to deeper formal training once you understand what you actually need to focus on. Because it was interesting your comment about I didn't know what engineering was. Well, hey, I picked engineering and I had no idea either until I had work experience. And I think that's it, until you actually start work and figuring all these things out and it becomes real to you, that you're able to then go, actually, you know what, this was the best place to put my energy in terms of learning, and because I'll get the most outcomes out of it. So, tapping into experience and moving into those places. And look, most workplaces, part of the role of workplaces is to train people. I mean, nobody at any level of an organisation generally comes in 150% perfect for that role. Everyone is learning, and the organisation is always putting support around people to gain skills and competence in that space. And you create networks of people as well around you that can help support you in that transition. And maybe that's more formal, sort of mentorship, or it could be quite informal. So, look, I think that's the other part, is just that exploration through doing.
Yeah.
We might open it up to the floor now. Does anyone have any further questions for the panel before we stop? I'll start with you.
I'm interested in the industry and university collaboration. When I was a young graduate, we had lectures given by the industry. So they would come in and teach us a 6-month course. So we actually learned what a protection engineer was in the electrical industry because he came from emissions and he did a 6-month course. I've not heard of that anymore.
So I can take that one, I guess, again. So it's fragmented, I think, through our program, and comes very much down to the individual academic, how much they actually engage industry in their programs. So that's what's been happening at the moment. But what I know from running a course is that they're the highlights of a course to actually have someone come in and speak or to go off to a site visit. So I actually take my students off to the blood bank because I teach a senior elective in bioprocessing, and what better to see biological molecules being processed into a product than at the blood bank. But so it's been fragmented and down to the individual academic, but what we're doing now is to more formalise that at the faculty level and to have real industry input into the individual projects. So I think what we'll start and see more of it for is project-based learning. So then you can see many types of engineers and the way they can come together and work collaboratively as a team, rather than just relying on the fragmented involvement of industry networks. So the message is we're changing, and we're seeking much more industry involvement in our training than we have perhaps of late.
I have a question about. Hello, I have a question about an individual that's have probably 15 or 20 years of experience in industry and thinking of taking a PhD degree. Now it's a bit hard for someone who has been in industry and practical thinking for like this age, turning into or understanding the academic requirements or even talking the academic language after all these years of industry. So what are the sort of advice or tips that you can give to someone who has been in industry for so long and wanting to have this smooth transitioning into the academic field, pursuing his degree in line with having like the practical industry experience progressing at the same time?
Do you want to start?
Industry PhD, yeah. Megan's laughing at me because in her class I'm always trying to recruit the undergrads to come and do our industry PhD program. And I think this is a really great example of how that process can really benefit a very wide spectrum of people. In the way that this program is being set up, there are a couple of different streams. Some very much suit that, fresh out of undergrad going straight into PhD and doing a PhD project with an industry sort of collaborator. But there are also opportunities to have essentially engineers who are working in industry whose work is essentially at the level of academic rigor of a PhD project, to have their company in a relationship with UNSW work out ways to recognize the caliber of that work, because obviously we've talked a little bit about IP, and so there are some things to work out there, but to recognize that and facilitate their staff and their engineers earning PhDs through the work that they're already doing, as well as sort of kind of a midway point where you are not entirely just fully doing your work and it's recognized as a PhD, but you are stepping into that sort of midway point between pure academia and pure industry. So that, I think, is a really good kind of formal program. And then if I had any personal suggestions on the mindset of going back into academia and the kind of student or the learner role after being out for a while, because I did work for a little while before I came back, I think it's not actually as big of a switch as we kind of make it out to be in our heads before we do it. I know I was a little worried that I would come back and go, but I'm not doing things, I'm not making things, I'm not my own person the way that you kind of are when you're a worker as opposed to a student. But the beauty of PhD is you're essentially handed a big project that you get to work both autonomously on and also as part of your team. You're still using those collaborative skills that you have. You're still driving forward and creating your own product. You're just doing it with a little bit more of a structure around you, at least at UNSW, a little bit more of a structure around you. So I think it's certainly a bit of an adjustment, but it's not too much of a switch, in my opinion.
I'm sorry, I've been told that the food's ready, and I've been told we have to wrap up. So the panel, if you've got more questions, fine. The panel will be available to chat feel free to approach them after we leave, and we mingle with drinks and food out there. So,
Great. Yeah, can we all just put our hands together and thank our 4 panellists for tonight and their great insights. Thank you. So as Ian said, there's food and drinks outside. You're welcome to network amongst each other and with us.
thanks, panel.
Thank you.